Unit 1 Study Guide Part 2. Great, we're on number 3. Katerina is making picture frames of various widths for 5 by 7 photos. The frame, with a width of X inches on all sides, has an inner rectangle that is the space for the picture. The polynomial expression that represents the area of the frame is 4x squared plus 24x plus 35. This will be the total area of the frame and picture together for any value of x. All right, so the situation they're talking about, let's just say a picture frame. They said they have an inner rectangle, and then this is really where the picture goes. Okay, the polynomial 4x squared plus 24x plus 35 represents the area. So remember, area is length times width. But if we look at the question, all it's asking for is what is the leading coefficient of this polynomial. Okay, so remember, a coefficient is a number next to the variable, in front of the variable. So this would be a coefficient. This is a coefficient. And this really is just review. Remember, this is a constant term. So yeah, it's a number and it looks like this, right? But it doesn't have a variable. And remember, if it doesn't have a variable, it's a constant because that number is never going to be anything else other than 35. Remember, with the variable, it makes the term vary. Here's our variable. I'm just going over the different parts of the expression right now. We have another variable. We have our exponent. Okay, so they want to know the leading coefficient. Well, leading, if you can think of what's the line leader, okay, in this case, it's going to be 4. 4 is the leading coefficient. And that's because this is in standard form for polynomials. Remember, polynomial standard form states that it has to go in order from the exponent from greatest to least. So notice we have our x squared before our x. So if I had the 24 out first, front, 24 wouldn't be the leading coefficient because it wouldn't be in standard form yet. So you always have to make sure that it's in standard form before classifying if it's a leading term. This is the leading coefficient. This whole thing right here is the leading term. Okay, number 4. Select all of the expressions that justify why 8 to the 1/4 is equivalent or equal to the 4th root of 8. Now this is similar to number 2 when they had us rewrite into radical form. Okay, they're just showing the rational exponent, and then they showed putting it in radical form. Remember, the denominator goes on the outside, becomes the index, and then our 1, our numerator, technically goes on the inside. They just don't have it written here because remember, we don't write to the first power, although you can if you need to. Okay, so all they're showing is that this is the same. Now, if we're looking at our expressions that they give us, part A says 8 to the 1/4 raised to the 1/4. Now, I'm just going to simplify this to see or show you what we get. Remember, with an exponent on the outside of parentheses, we have to distribute it in. And we can only distribute exponents to other exponents. So 1/4 times 1/4 is 1/16. So that becomes 8 to the 1/16. Now that alone doesn't really look like what they're asking for. Part B, they have 4, 8 to the 1/4. So it looks like they have the same thing here. They just put a coefficient out here of 4, or a number multiplied on the outside. Okay. that we didn't really talk about because we don't do that. Why would they just automatically put a 4 out there? Doesn't make sense. Okay, so if we look at C, 8 to the 1/4 to the 4th, I still have to distribute. Okay, and I can rewrite this as a fraction to make it easier for you to see, because we're multiplying a fraction by a whole number, but we can make any whole number a fraction by putting it over 1. So 4 over 1 times 1 over 4. If you notice, these 4's cancel, and we're just left to it with an 8. So I'm going to come back to that one in just a second because I want to show you D first. Okay, D, 8 to the 4th, raised to the 1 over 4. If you notice the difference between C and D, the only thing that changes was they were flip-flopped. So my 1/4 is on the inside here, but on the outside over here. We would still distribute this 1/4. 1/4 times 4, it still becomes 1. So we have 8. We're looking for the ones that have an exponent of 1. That is why C and D, and you already probably saw it circled, are the answers. We need those to cancel out. If I look at E, I'm not even gonna bother looking at that one because we didn't do anything like this. We're not gonna take this and make it the exponent, okay? So I know this one can be a little confusing. Just remember you're looking for the ones that end up with an exponent of 1. Okay. Number 5. Is the following expression rational? Explain why or why not. Okay, remember to be rational. I've been saying it in class this whole unit. Rational means fractional. If it can be written as a fraction, it is rational. So you kind of see that I already have the numbers up here, and I kind of separated each one. That's because 1 over 5, well, 1 over 5 is a fraction, so of course it's rational. The cube root of 27, the cube root of 27 is, remember, 3 times 3 times 3. For a cube root, we need a set of 3 to come out of the house. So 3 times 3 is 9, 9 times 3 is 27, which is where I'm getting that 27. Since I have a set of 3's, 3 would be the cube root of 27. 3 can be written as a fraction, 3 over 1. Any whole number can be written as a fraction. So that's why I'm saying this one's rational. If I add these two rationals together, I get another rational right here. Over here, the square root of 25. Well, 5 times 5 is 25. So 5 is the square root of 25. 5 over 1, just like I wrote the 3 over 1, it's a rational number. So I add another rational. Well, a rational plus a rational is another rational number. We're adding the square root of 5. This is a non-perfect square. Remember, we said non-perfect squares are irrational. It's one of the most common ones. Pi, non-perfect squares, number or decimals that go on and on and on forever, but are not repeating. All those are irrational numbers. But what happens when I add a rational and an irrational? Well, if you see here on the standards, okay, the sum, that means adding, of a rational number and an irrational number is actually irrational. And that would be my explaining. Why is it? Okay, so the question, is the following expression rational? No. No, the expression is not rational because the sum of a rational and an irrational number is irrational. And they're asking if it's rational, so it's not. Okay, so it's kind of just a definition question. Number 6. When multiplying exponents with the same base, how should a student apply the rules for exponents? So remember, we did the wheel in class for the rules for exponents. So you kind of have to think about, okay, which rule are they going to be talking about? To evaluate the expression, 7 to the 3/4 times 7 to the 3/4. Well, I already kind of said it right there. I'm multiplying. If I'm multiplying, then I'm using the product rule. But remember, with the product rule, they have to have the same base. Do they have the same base? Yes, the base is 7. So just like earlier in the study guide, I think that was problem number 2. Keep the base, and I'm going to add the exponents. So keep 7, and we're going to add 3/4 plus 3/4. This is kind of nice because I don't have to make a common denominator. They already have a common denominator. So this one's going to be faster. 7 to the 3 plus 3 is 6/4. Now remember, I said in the beginning, anytime we have something that can be simplified, we need to simplify it. So 6/4 can be reduced because they're both even numbers. A good number to start off with is 2. 2 goes into both of them because it's even. So if I divide the top by 2 and the bottom by 2, because whatever I do to the one, I have to do to the other. 6 divided by 2 is 3. Divided by 4 divided by 2 is 2. Okay, let's see if that's what the question was asking. Explain in detail, including how to write the answer in radical form. Okay, so we actually have to write out what we did. So when, let's see, using the product rule, because that's what this is again, we need to have the same base and then we, keep the base and add the exponents. And that's what we just said right here. Keep the base, kept the 7, and then added the exponents. When writing in radical form, let's see how to write it in radical form. I'm going to go ahead and write it in radical form first, and then I can explain it. The 7, our base, becomes our radicand. Our denominator becomes our index, and our numerator becomes our exponent. So I'm not going to really write that out right here, only because I'm running out of room. But all we have to do, keep the 7, the base becomes a radicand, denominator, index, numerator, exponent. Remember that this really becomes raised to this power, and I kind of said this in class. And we're going to take the second root. So if this said 2/3, I'd be raising to the second power and then taking the third root. And you see here, that is my root. 2 is my root. I'm taking the second root.